Flack math! Give me some math and I'll give you some flack. Flack math!
Okay, so a mid-segment of a triangle. Is the segment that joins the midpoints of two sides of the triangle. Okay, so if I have a triangle here, like this, so this is the segment that joins midpoints of two sides of a triangle. Okay, so over here, like this is the midpoint, and this is the midpoint. This guy would be the mid-segment, that one right there. Okay, you can also find this midpoint here, and this midpoint. So these are the mid-segments. Okay, so far so good? It kind of combines the two parts of the definition, or it's just the line segment that connects the midpoints. Okay? And obviously there's going to be three different ones because there's three different midpoints. So here's what the midsegment theorem says. So this is theorem 55.1. The midsegment theorem. The segment joining the midpoints of two sides of a triangle is parallel to and half the length of the third side. Okay? So that kind of makes sense. So this guy is half the length of the bottom side. This line segment is half the length of this. This is half the length of this. Kind of makes sense because it's going halfway up. It's parallel. So if it goes halfway up, it's going to, and at the very top, it's totally done. So in between 0 and this, halfway is going to be half of that length. That makes sense. Okay, so there's two things in this theorem. It's parallel and it's half the length. Okay, so I'm going to say, let's see, let's shorten this a little bit. Mid-segment of two sides of a triangle is parallel and half of the length of the third side. Parallel to and half the length of the third side. Okay? Can you guys remember that? Okay, now let's do an example. So let's see here. Oh, this is way too easy. I'm embarrassed. So find X and Y. Let's say that this is the mid-segment of these two sides. Let's find X and Y. What's X? What's X? What's your gut tell you? Is your gut talking? Mine is speaking, but not math. Well, it is. It's speaking and yelling quantities of pasta that my wife packed for me. It's really good. She just kind of threw it together. You know how she does that. Okay, what's your gut tell you? What's X? This is 7, so what's that? What's this length? Shout it out loud. Do it. What is that?
Would be like 2, because it's 5 and 7.
Okay, don't shout that out loud. So this is 7. And remember the mid-segment theorem said the mid-segment is going to be half the length of the third side. This is the third side. So this is the mid-segment of these two sides. So this is going to be half the length of this. So what's X? You're going the wrong direction.
Oh, okay.
14. So your gut, something's going on with your guts because this looks longer than that side. And both of you gave me answers that are like shorter. I'm like, you must be really hungry and your gut's not communicating properly. All right, well, what's Y? Which doesn't really have anything to do with the midsegment theorem, but I mean, it kind of does. What's Y? What's your gut tell you? 5. This time your gut's doing well. Because this is the midpoint, right? Because the midsegment connects the midpoint of each side. So if this is 5, this is 5. That midpoint cuts that segment in half. Does that make sense? Okay, good. Okay, good. All right, next. Example 2 goes through a little proof. And what kind of proof do you think we could make out of this thing? Like, how could we prove that things are parallel and things or things like that? So if we just say that D is that these are the midpoints, what kind of proof do you think we can make? Any ideas? Well, here's always a good place to start. When you're trying to figure out a proof, a lot of our proofs in this class have to deal with similar triangles or congruent triangles. So I can see 2 similar triangles, at least that I think are similar triangles, right? This one looks similar to this. And how do you prove that triangles are similar? Well, you have to prove that all the angles are the same. Well, this angle is the same as itself, and this angle is the same as this angle because they're parallel lines. Okay, so because they're corresponding angles, so you could say that the triangles are similar, and then you just have to figure out the length. Well, if this is the midpoint, then this is going to be 5. Whatever this is going to be half of this. So the proportion, the scale factor is times 2. So then you can figure that out. Okay, so we won't go through the proof. We're just going to go on to our next theorem. So this is 55(2). All right, 55(2) says, if a line is parallel to one side of a triangle and it contains the midpoint of another side, then it passes through the midpoint of the third side. Okay, so if we have this scenario where we know this line is parallel and it hits the midpoint, then basically it's a midsegment. So this is kind of like the converse of the midsegment theorem, right? Well, here's what it says officially. If a line is parallel to one side of a triangle, so basically if this line is parallel to that bottom side, which it is, and, so there's an and it passes through or it touches the midpoint of another side. So it doesn't even have to say both sides, it's just another side. So if we know it's parallel and it passes through like the midpoint of that side, if that's what we know, then we can say this. Then it passes through the midpoint of the third side. Okay? So in definition, if it passes through the midpoint of 2 sides, that's a midsegment. In other words, midsegment. So this is like the converse of theorem 55-1. Okay, 55-1 says if this is a midsegment, so basically if it intersects the two midpoints of two sides of a triangle, then it is parallel and it's half the length. Okay, so the only thing we didn't go over in 55-2, the converse, is the half the length part. Okay, so it's not officially the converse, it's not completely the converse, but it's pretty close. Okay. So now we can kind of do the opposite here. So here is example 3. We're going to identify the midpoints of the sides of a triangle on a graph. So here's what the graph looks like. There's one vertex of a triangle. There's another vertex. So this is at -2, 4. This is at 2, -1. And then we're at 6, 2. Okay. So if I connected these dots, that's what the triangle looks like. And so here's what I want to say. This is M, N, P. So this is triangle M, N, P. So triangle MNP has vertices, -2, blah, blah, blah. QR is the midsegment of MNP. Okay, so QR, it goes from this point to this point. Calling it QR. All right, so now I want to find the coordinates of Q and R. Okay, well, if you graph this perfectly, you'd be able to tell, right? How far to the right does it go over? How far up? Well, it looks like it goes over 4 to the right and then up 1/2, right? And what does R look like? It looks like it goes over 2.5 and then goes up exactly 3. But how do you know for sure? How do you figure out this coordinate? You guys remember how to find the midpoint on a graph? Well, you could do it graphically or algebraically. Which way do you want to do it? Okay, so the midpoint is this. The average of the x's. x1 plus x2 divided by 2, and then the average of the y's, right? So I want to find the midpoint of this line segment here. So let's see, it's -2 plus 6, which is 4 divided by 2, which is 2. No, what am I doing wrong? Oh, I'm doing the, yeah. 4 divided by 2, which is 2. It looks like I graphed it a little bit wrong, but that's okay. So then this is going to be 2. So this is 4. See how I got 4? -2 plus 6 is 4 divided by 2 is 2. And then 2 plus 4 is 6 divided by 2 is 3. So that R is at 2, 3. Graphically, you can look at it, and it's just halfway between -2 and 6. Well, between -2 and 6, that's 8 units. So if I go over 8, it's right there. That's halfway between -2 and 6. And then the y value, it's halfway between 2 and 4. Well, that's easy. What's halfway between 2 and 4? 3. Okay? So let's see if you can do Q. Find Q. Find the midpoint. Find Q. The midpoint of P, or yeah, NP. So you can do it graphically or you can do it algebraically. I think we were pretty spot on when we guessed. What'd you get for Q? You guys know how to do that? So what's halfway between 6 and 2? 4. What's halfway between 2 and -1? Well, algebraically, you could add them and divide by 2. 2 plus -1 is 1 divided by 2 is just 1/2. But if you look on here, halfway between -1 and 2, it's going to be in between 0 and 1. So 1/2. Okay. So do you guys think you can either handle this algebraically or graphically or both? Okay. Ava, are you going to fall asleep?
Just hungry.
I am starving.
Yeah.
Okay, we got one more lesson, and then we can chew on our fingers. All right, let's do 56. Is that the Austin Powers song? No. I don't watch that. It's inappropriate. Oh, it's Rock and Robin.
You can't get more wholesome than that.
You can't what?
You can't be more wholesome than that.
Yeah, Rock and Robin? Yeah, that's pretty wholesome. Actually, you know what the Robin, just kidding. It's just like Puff the Magic Dragon. Okay, we talked about 45, 45, 90 triangles. What's the big deal with that? Remember when we had like, this was 7 and this was 7. What's this?
Square root.
Yeah, so 7 radical 2. So whatever that side is times radical 2. Okay? Now we're going to do 30, 60, 90 triangles. 30, 60, 90 triangles. So these look like this. So if I had 7 here, if you're given 1, you can find the rest. Okay? So let's see if we can do this. If I made this into a triangle here, full triangle, so I doubled it. Remember, this is 60 degrees. This is 30 degrees, 30 degrees. So what would this have to be? What kind of triangle is this? Do you remember the name? It's like 5 syllables. What kind of triangle is it? Spaghetti and meatballs? Is that what you're thinking?
Isosceles.
It is officially an isosceles triangle, but isosceles is at least 2. But all 3 are the same. So what is that? Equilateral. Okay? So if this is equilateral, that means all these sides are the same. So if this is 7, which is half of a side, what's this? That's going to be 14, right? So in a 30, 60, 90 triangle, if you have the short leg, the hypotenuse is going to be twice the short leg. Okay? So this is always twice, 2 times the short leg. Okay? All right, now we just have to figure out that. Should we use the Pythagorean theorem? So a squared plus b squared equals c squared. So that's 7 squared plus unknown squared equals 14 squared. That's 49 plus b squared equals, what is that? 216. You guys know? We're going to go with that. Okay, so b squared, subtract 49 from both sides. B squared equals
It's 196.
Oh, 14 squared was 196. Good job. 216. I'm rusty. Okay, so this is going to be b squared is going to be, what is that? 147 degrees. Okay. All right. Now find the square root of that. Square root of 147. Well, guess what? There's a 49 in there. So, and then there's 3 left over. There's 3 49s in there. So that's just 7 radical 3. So guess what the shortcut is? Instead of tagging on a radical 2, you're going to tag on a radical 3. So if this is elephant, this is 2 times elephant, and this is elephant radical 3. Okay? That's the shortcut for a 30, 60, 90 triangle. Okay? So if I did this generically, I would do this in a 30, 60, 90 triangle. If this is x, this is going to be 2x, and this is going to be x radical 3. You can put x, you can put any number for x, except 0, I guess, or any negative numbers. So a lot of numbers you can't use. Okay, just double it to get the hypotenuse, tag on a radical 3, or multiply by radical 3 to get the longer leg. So to go backwards, you have to divide by radical 3. Or if you're just given this, this is nice. If you're just given that, you just cut it in half to get the short leg. And then you just tag on a radical 3 to whatever that was. Okay? So let's do some examples and then we'll call it a day. This is example 2. Ready? This is 10 centimeters. I want to figure out x and y. See if you can do that.
Just be 5 and then 5
Yeah.
3.
It would be if this was the hypotenuse, it'd be 5 and then 5 radical 3.
So,
But this is the difficult scenario.
so is it going backwards? Is that it?
Yeah. So if that was a hypotenuse, remember the hypotenuse is twice the short leg, but the longer leg is the short leg times radical 3. So this is the scenario which is the most difficult. So you have to divide by radical 3 to get the short leg. And you can't have a radical on the bottom. You can leave it in terms of radicals. You don't have to multiply it out, but you can't have a radical on the bottom. So what does this look like so far? You're just dividing by radical 3, right? I'm not going to use green. So 10 over radical 3, but this is a no-no. How do you get rid of that radical 3? Yep, so you have to multiply by radical 3 over radical 3. You can do that because you can do the same thing to the bottom as you do the top. This cancels out to just 3, and then you're left with this mess. So there is the short x equals 10 radical 3 over 3. The shortcut to that is, yeah, you're still tagging on a radical 3, but then you divide by 3. So if this was elephant, this would be elephant radical 3 over 3, which is weird to think about it that way, but you can. So now, how do you get y? How do you get y? I think I just marked my head. Do I have a blue mark on my head? Right around there. Is there a blue mark?
Yes.
Okay, thank you. I look really bald when I'm this close. Okay, anyone know what this is? Anyone know what y is? What'd you get? You have your mouth open.
Sorry.
Because I think you're going to say something.
I think I'm going to say something, but I forget.
So what's your guess? Just go for it. Even though you failed in the beginning part of this class, when you guessed, it's okay. It's a new day. Not really, it happened earlier today, but it's a new moment, okay? Don't be afraid to fail. Geneva, what do you got? How do you get from here to here? What do you do again?
You just add on a radical 3.
No, that's going from here to here, or like short leg to longer leg. But to go from short leg to hypotenuse, what do you do?
You double it.
You double it. How do you double a fraction?
I don't know. Oh, you just do both to the top and bottom?
Well, if you do the both 2 and 2, then it's just multiplying by 1. You want to multiply by 2, so just that. So you just double the numerator. So this is going to be 20 radical 3 over 3. Okay? You see how that doubles it? When you double a fraction, you just double the numerator, or times 2 over 1. Okay? This is the most difficult scenario when you're just given the longer leg. That makes it more complicated. But when you're given like something else, like the hypotenuse or the short leg, that's nice, because then it's an easy, if you remember your shortcut, then you can figure it out really easily. Okay, so I think that's about it. I mean, we could do a few more examples, but I think you got it. This might be a good one. Let's just do one more. I'm sorry. And then, yeah.
Please.
No?
Don't do it. No, it's fine.
Okay, you don't have to do it, but I'm going to do it, and you can just watch. So I want to find the area of an equilateral triangle with the side of 5. Okay, so I'm going to find the area of an equilateral triangle. Find area of equilateral triangle. It sounds like an easy problem because it gives us a side length. Well, if that doesn't work, remember find the area of a triangle, you need the base times the height of a triangle, not side length times side length. Okay, so here's what the triangle looks like. So what do you need to find the area of that?
Based on site.
Yeah, so you need the height, which it doesn't give us, but when I draw the height, this makes two 30, 60, 90 triangles. You see them? Okay, so that this is 60, this is 30. So now I can find this. Well, first of all, how do I find that? Well, the longer leg is usually the last one you find, but it gives us the hypotenuse. So what's the length of the short leg? What? 2.5. It's just half of that, right? So you can just say 5 over 2. And then how do you find the short leg once you have the long leg? Once you find the short leg, what do you do? What do you do? You know, you're just not saying. You remember this, the little formula here? This is x, 2x. What's this? X. Radical 3. So you just multiply by radical 3. So this is 5 radical 3 over 2. When you multiply by a radical, if you multiply by a fraction by a whole number or a radical, you just do the top because it's radical 3 over 1, whatever. So now you got the base and the height. So area equals base times height all divided by 2, right? Or 1/2 base times height. So the base is 5, right? The whole base is 5. And then the height is 5 radical 3 over 2. So if I just multiply all the tops, because that's just 5 over 1, right? Multiply all the tops, you get 1 times 5 times 5 times radical 3. 25 radical 3. 2 times 1 times 2 over 4. There's your area. So that is a very messy area, but that's how you find the area. The area of a triangle, base times height divided by 2, or 1/2 base times height. Okay? How's that feel? You feel good? You feel good?
Black math, give me some math and I'll give you some flack.